What is a factor? What's a factor?
A factor is a number in a multiplication problem that you are multiplying with.
Yeah, so it's the numbers that you're multiplying to get a product. So factors are what you multiply together. Okay, so the factors of a number are the whole numbers that you can divide without leaving a remainder. So if you look at these two examples right here, okay, a factor times a factor, that's what Avon was just telling us. A factor is the number you multiply together to get a product. So it can be factor times factor equals total, or you can take the total divided by a factor to find the other factor. So for example, the factors of 6. What numbers can be multiplied together to give you 6? If I tell you 1, what would the other factor be to equal 6? 6. Okay, so I have 1 and 6. Those are factors. Okay, 2 and 3 also make 6 on the slide right before. 1 and 6. 2. All right, if I look at this, I've got a bunch of different groups up on the board. I have 6 groups of 1. Notice how each green dot is circled by a circle. Okay, so I have 6 groups. Everybody understanding where my 6 groups come from? Of 1. Look next to it. I have 3 groups of 2. I have 2 groups of 3, and here I have 1 group of 6. This is basically representing the same things I just wrote. 3. 2 groups here, 3 groups here, 1 group here, 6 here. We cannot separate 6 items into equal groups of 4 or 5. So 4 and 5 would not be considered factors of 6, not equal groups of them. List the factors of 20. Okay, first thing I want to do is I want to list all of my factors. I'm going to start with 1. What do I multiply by 1 to equal 20? 20. So this is what I like to call the rainbow method. If I do 2, can 2 go into 20? Okay, 2 times what? 10. Could 3 go into 20?
No.
Could 4 go into 20?
Yes.
4 times what?
5.
Okay, so I've got 5 there. Could 6?
No.
Could 7?
No.
8?
No.
9?
No.
And I already have 10. So guess what happens? Since I already have 4 and 5, since these two numbers are right next to each other, like on a number line, that's it. That's all I have left. Once you get to a spot like that where the two numbers multiply together, you've already got them all listed. This is why I call it the rainbow method, because when I match them up, it makes a rainbow. Yes?
I just realized something, but it goes like a pattern. Like on the 1, 2, and 4, it goes up by 1, and then it goes up by 2,
Oh,
and
yeah.
it's going up by more. And then on the 5 one, it goes up by 5, and it goes up by 10.
That's interesting. I didn't notice that. I like that. Okay, factors of 23. Okay, I know 1 is a factor of every number because I can multiply 1 by the number itself no matter what number it is. So 1 times what?
23.
23. Are there any other factors that can go evenly into 23?
No.
Nope, that's it. Just 1 and 23. That's all. Okay, which of these numbers is not a factor of 30? Which of these is not a factor of 30? So that means you've got to look at each one. Can 2 be divided into 30?
Yes.
What can I multiply by 2 to get 30?
15.
Okay, so we know that this is a factor.
2 can go into any number as long as it's not odd.
Very good. So if it is an even number, it can always be divided by 2. Okay, can 3 go into 30?
Yes.
What do I multiply 3 by?
10.
10. So this is a factor. Can 4?
No.
Okay. What about 5?
Yes.
Times what?
6.
Good. So C on this one should be the correct answer.
It's kind of obvious because it's 30 and there's a 2 there. And then 3, it's obvious because 3 times 10
Mm-hmm.
equals 30. And then 5, you all know that too.
And y'all remember when we talked about divisibility rules before the break? We talked about how any number that ends in a 0 can always be divided by a 5. 5 can go into any number that ends with a 5 or a 0. So we know for sure that 30, since it ends in a 0, can be divided by 10 and 5. Which factors of 9 are also factors of 18? The first thing we should do here is figure out what my factors of 9 are. So what are my factors of 9?
1 and 3 and
1 times what is 9?
1 times 9.
9. Okay, so I've got 1 times 9. I know that 3 times itself, 3 times 3 is also 9. Okay, so now I want to look at these. Which of these factors are also factors of 18?
3.
Okay, so if these are all 9s. Now I'm doing 18. So let's list my factors for 18. 1 is a factor of 18, right? 1 times what makes 18? 18. Okay, can 2 go into 18? 2 times what is 18? 9. Is 3 a factor of 18? 3 times what? Okay. 4 cannot go evenly into 18. 5 cannot go evenly into 18, but these numbers can. So now what I'm looking at is which factors do 9 and 18 have in common?
1, 3, and 9.
1, 3, and 9 on both of them.
What do you mean? Oh, yeah.
See how we have those in common? Yes.
And if you don't count the 1, it goes 3, 6, 9, 18.
Mm-hmm. If you leave out the 1 and the 2. Yep.
But you just need to add a 12.
Mm-hmm. Okay, are there any questions? You want to do this again? You want to do it practice with 2 other numbers?
No, ma'am. I do not.
Okay, what if, instead of doing a question like this, what if I just gave you a question and said, okay, what are the factors of 24? Okay, let's always start with 1. 1 and 24. 2 and 12. 3, I'm going in order. 3 and 8. 4 and 6. Okay, this is another method I like to use to identify factors. This is what I call the horseshoe method. Anybody know why I would call this a horseshoe method?
Because you're making like a horseshoe.
Yeah, if you're going down like this, it loops back around. So I have, I list all my factors in order. 1, 2, 3, 4. 5 is not a factor. It loops back around because 4 times 6 is 24. Then it goes up 3 times 8, 2 times 12, and 1 times 24. When you get back around to the top again, then you are done.
But I was thinking of the horseshoes, like that, like curved part is like the 24, and then it curves down to the 4 and the 6.
No, it's a pumpkin because the top is off.
All right, guys, your assignment today is on page 172. Numbers 1 through 3 ask you to write the equation before solving.